Hello everyone, welcome to Pepcoding. So in this video, we are going to discuss the question diagonal order sum of a binary tree. So we will be given a binary tree and we have to print the sum but in diagonal order. So let us move to our binary tree. So this is our binary tree and talking about diagonal order sum of a binary tree. So you must first visit a question which is diagonal order traversal in a binary tree. So this is a separate question. If you haven't watched the video of this question, then first go and watch the video of this question. Then you can easily understand and relate this question with this one. So what does diagonal order mean? So talking about from root, so this will be diagonal 0, this will be diagonal 1, this will be diagonal 2, and the nodes coming in the direction of diagonal 0 will belong to D0, and coming in the direction of D1 will belong to D1. These all nodes will belong to D2. So specifically D0 will contain 1, 3 and 7, and D1 will contain 2, 5, 6 and 13, and D2 will contain 4, 8. And in this question what we have to do, we have to find the sum. So this will contain 11, this will contain 26, this will contain 12. So overall we have to find the sum. Okay, so think about the solution approach. So what we'll do, we'll take help of a queue and we'll be storing our answer in an answer, and we'll be taking a variable sum in which we'll store the sum of these nodes. So how we're going to implement this? See, firstly what we'll do, we'll add the root value in our queue. Okay, and then we'll check its left child. We'll firstly the size is 1. So what we'll do, we'll try to remove the element from queue, and while removing, what we'll check whether it is having a left child. If it is having a left child, we'll add it into this, and we'll add this 1 into our sum. Initially it will be 0, and we'll add this into our sum while removing. We'll add this into sum, and we'll check if it is having any left child. If it is having any left child, then we'll add in q, and if it is having any right child, then we'll add in our sum. Okay, then again for 3 we'll check if it is having a left child, then we will add in our q, and we'll check whether it is having any right child. If 3 is having a right child, then we'll add into our sum. Again we'll check if 7 is having any left child. No, 7 is having no left child, so we'll not anything in our q, and we'll check if 7 is having any right child. So 7 is having any right child? No. So from here we have achieved a sum value. Okay, and we'll reduce the size of this q, and now the size of q will be 2. So we have achieved the sum value for our diagonal 0. How? 7, 3, 10 plus 1, 11. We'll store this sum in our D0. Okay, so again what we'll do, again we'll start from 2. We'll take a fresh variable, we'll again initialize sum with 0, and what we'll do, we'll check for 2 now. We'll check whether 2 is having any left child. If it is having any left child, then add it to the, firstly try to remove and add it to the sum, then check if it is having a left child and right child. If it is having left child, then add it to q, and if it is having right child, then add it to sum. Okay, now again we'll check for 5. If 5 is having any left child, no. 5 is having any right child, no. So from here what will happen, 5 is not having any right child, so we'll leave from here, and we'll check whether the size is still 0. No, size is 1. We'll come out of this sum when our size will be 0. So we are still having a node which is 6. So we'll remove 6 and we'll add 6 into this, and we'll check its left and right. Whether it is having any left child? No. So is it having any right child? Yes. So we will add in sum. Okay. So now again we'll check for left and right. We'll check for left and right. Is 13 having left child? No. Is 13 having right child? No. So again we'll decrement the size. So now it is 0. Now we'll come out of the sum, and the sum will be containing 26. Okay. So our D1 will contain 26. Now till here size is 1. Now for again this sum will become 0, and we will be checking for 4. We'll remove 4, add it into sum, check for its left child. Is it having any left child? No. So we will not add into Q. We'll check for right child. Is it having any right child? Yes. So we'll add in sum. Okay. So this will become 12. So again we'll check for 8, left and right. Is it having left child? No. Right child? No. Then we'll decrement size, and now we'll check this size is 0, so we have stored our sum. So this will contain 12. And now we'll check for size of Q. Now the Q is empty. So this all work we were doing till our Q size was greater than 0. So our outer loop will be having the condition while Q dot size is greater than 0. And as soon as Q dot size becomes 0, our answer will be returned. Okay. So now this thing we'll implement in our code. So let's move to our code section. So this is our diagonal order sum function, and our first work is to create a queue. So now what we'll do, we'll add our root, or we'll push our root value in queue. So next step, then we'll start a loop from Q dot size. If it is greater than 0, then we'll do some work, and also we'll maintain a answer which will return at last of int type answer. Okay. And our next step to again work on size. And we'll do this thing till size is greater than 0, and we'll also decrement the size. Okay. Now we'll store the removed node somewhere, because we have to do some work on our removed node. What work? What kind of work? We are supposed to check whether it has its left child. It is having its left child, we'll add it in our queue, and if it is having a right child, then we'll add in our sum. So we have to keep it safe. We'll remove from the front. Okay. Now we will again start a while loop. Node not equals to null ppr. Okay. So right now we are here. So what we'll do, we'll add the value of node in sum. Okay. And next we'll check condition if node of left not equal to null PTR. Then we will push it in the queue. So queue dot push node of left. Then what we'll do, we'll make node equals to node dot right. Sorry, outside the if condition. See, if you are not getting this thing, then we'll be discussing the dry run, then we will get to know what we are doing over here. Okay, sorry, it will be some value. And then we'll return the sum. We'll return our answer. So let us do the dry run, a small dry run. See, first step is we'll create a queue and we'll insert the root value in our queue and size will be 1. And next step is we'll enter into this size and we will remove this one, and where we'll add, we'll also create a sum and a answer. Okay, so we will remove this queue, this node from queue, and we'll check if this node is not equals to null. Yes, it is not equals. Then we'll add this, its value, in our sum. Initially it was 0. Initially it was 0. 1 will be added. It will be removed. And now what will be checked? If node dot left not equals to null. Yes, it is not equals to null. Then push it in the queue. So push it in the queue, and then we will call node dot. Then we will make this node point to this node. Okay. Now what will happen when, then again we'll enter into this while loop. Node not equals to null. Yes, node not equals to null. This is 3, and we'll add this. We'll add this 3 in our sum, and we'll check its left. We'll check its left. If it is not null, we'll push it into the queue, and then we'll make it point to 7. Okay. Now again we'll come into this node dot right. Node dot right is pointing to this 7. Okay, 7 is having no 7 is having 7 is not equals to null. We'll add this 7 into sum, and we'll check its left. Its left is null, so we'll add nothing. Its node will point to its right, which is null. Now when the condition will be checked, it will become false. We'll come out of this while loop and we'll enter into this size. So initially size was 1, it will become 0. This condition will also become false. And now what will be done? Now we will come out of this while loop and we'll add this sum into our answer. So let me create another answer. We'll add this answer into this. Okay. So for next also, now the size is 2. Now we will enter again into this while loop, and the same thing we'll do for this. We'll check size, we'll remove from front, and we will check if it is not equals to null, then we'll add its value. Now the sum has become 0. We'll add its value and we'll check its left. If its left is not null, we'll add into the queue and we'll move to its right, and again we'll check its left. If it is not equals to null, then we'll add it in queue, but it is equals to null, so we'll add nothing to queue. Now we'll come to its right. It is pointing to null, so again this condition will become false. We'll come out of this. Size is now 1. Okay. size is now 1. So now 6 will be removed. Now 6 will be removed and we'll check 6 and we'll add 6 to its sum. And we'll check if 6 left of 6 is not equals to null but it is equals to null. So now we'll check it. We'll make it this node. Okay. So again we'll come into this while loop. 13 is not equals to null. We'll add 13. We'll check its left and right. So left is nothing, right is null. Node will be pointing to null. And this condition will become false. So we'll come out of this while loop. Then again size is 0. So we will also terminate from this while loop. Okay. And we'll be pushing this some value in answer. So some value will be 26 and this will be pushed into our answer. Okay. So till now we have completed and now the size is 1. And again we will do the same thing. So I hope you have got this thing. Now we will run our code. Okay, so Q, spelling of Q, where in line number 21. Okay, so this will be Q. Sum plus sum. Okay, so we haven't declared the sum. So here will be int sum equal to 0. Okay. Because when we were coming, see, when we were terminating the while loop of size, terminating the while loop of size, so it will be here when we were terminating the while loop of size. Coming out of the while loop of size, then it was becoming 0. Sum was becoming 0. So accepted, submitted. Okay, so I hope you have understood the problem and the solution. So we'll be meeting in another video with another question. So thank you for watching.